First definition of a function. A relation is said to be a function. Let us consider two sets A and B. Let us say we have three different elements here. A relation from A to B is said to be a function if every element of first set is uniquely associated with an element in second set. What does it mean? Now A is associated with X, B is associated, A is associated with Y, B is associated with X, C is also associated with Y. Now this relation can be called as a function if every element of first set is uniquely associated with an element in second set. If you observe here, A is associated with only one element Y, B is associated only with one element X, C is also associated with only one element Y, and hence this relation can be called as a function. This is an example of a function that can be stated like this. Here this Y is known as image of A, X is known as image of B, which is represented like this. Image of A is Y, image of B is X, image of C is also Y. So here Y is known as image of A and A is known as inverse image of Y. Same thing can be written like this. A is known as inverse image of Y, B is inverse image of X, even C is inverse image of Y. This is what is meant by image and inverse image or pre-image. Another name for inverse image is pre-image. Suppose, so when we can call a relation as a function? When every element of first set has unique association with an element in second set. For example, here A is associated with X and A is also associated with Y. This is not a function. Why this is not a function? Because A has more than one association. As I said, for a relation to be called as a function, every element of first set should have only unique association, only one association. Here A has two associations and hence it is not a function. A is associated with X, B is associated with Y. This is also not a function. Why? Because C has no association. Every element should have only one association. If any element has more than one association like this, or if any element doesn't have any association, then it is not a function. This is what is meant by a function. Next, what is domain, codomain and range of a function? If f maps A to B is a function, if f maps A to B is a function, then the first set A is known as domain and the second set B is known as codomain. So if any function f maps from A to B, the first set A is known as domain and the second set B is known as codomain. Then what is meant by range? Already we know what is meant by image. Let us say A is associated with X, B is associated with Y, C is also associated with Y. What are the images here? X is image of A, Y is image of B, but Z and W are not images of any elements. Now the range is defined as set of images, which is denoted with f of capital letter A. So what is the definition of range of a function? Set of all images. Why Z and W are not there? Because these two are not images of any elements. So range is only set of images. Codomain is second set. Here codomain is second set. Second set means x, y, z double. So remember, range is always a subset of codomain. So what is the definition of range? It is a set of all images. Codomain means the complete entire set. Second set B. And if you observe this, here range is always a subset of codomain. So if f maps A to B is a function, the first set A is known as domain, second set B is known as codomain. Range is nothing but set of all images denoted by f of capital letter A, and range is always a subset of codomain. This is what is meant by domain, codomain, and range. Next, absolute value function or modulus function we say. Modulus function is defined like this. If x is any real number, mod x has two values, plus x when x is greater than or equal to 0, minus x when x is less than 0. Which means mod x is always 0 or positive. Don't think that minus x gives negative. When we write minus x when x is negative, for example, mod of minus 3. Before that, let us say mod of 5. 5 is positive. When x is positive, how to write mod x? X. That is, if the number inside the modulus is positive number, modulus of that is that number itself. Next, what is mod of minus 3? Minus 3 is a number less than 0. When x is less than 0, how to write minus x? Minus x means minus of minus 3, which means plus. So remember, mod x should be written as x when x is greater than or equal to 0 and minus x when x is less than 0. This is the best example. Mod of minus 3. Minus 3 is a number less than 0 and hence you should write minus x, that is minus of minus 3, which is plus 3. So what is the domain of mod x? What is the definition of domain? Domain means the set of all real values of x where the function is defined. Mod x is defined for all real values. Mod x is defined for all real values and hence its domain is capital. What is the range? It is a set of possible values of the function. How mod x will be always? Mod x is always positive or 0. So what will be the range? 0 or positive means 0 to infinity. 0 is included, so close the bracket for 0, and for infinity minus infinity always open bracket. So this is the domain and range of absolute value of x or mod x. That is a graph of mod x. Y is equal to x means straight line passing through origin when x is greater than 0. Y is equal to minus x is also a line passing through origin when x is less than 0. So that will be the graph. Even from graph it is very clear that graph is always above x-axis. Above x-axis means y will be always positive. Next, what is greatest integer function or step function? If x is any real number, then the greatest integer less than or equal to x is denoted like this. And we read it as step x. When x lies between n and n plus 1, where n is any integer, then step x is defined as n. If x lies between n and n plus 1, including n and excluding n plus 1, where n is integer, then step x is defined as 1, n. Which means, suppose if n is 0, 0 plus 1, 1. Then what is step x as per the definition? 0. If x lies between 1 and 2, if x lies between 1 and 2, including 1, excluding 2, then as per the definition, step x will be 1. When x lies between 2 and 3, including 2 and excluding 3, as per the definition, step x will be 2. So graph of step x will be as shown above. It looks like steps and hence the function is known as step function. Suppose if you take a negative number for n, let us say n is minus 2, then n plus 1 will be minus 1. Then as per the definition, step x will be minus 2. So based on these values, if we draw a graph for greatest integer function, it looks like steps, and hence the graph is, and then the function is known as step function also. And step x is defined for all real values of x, so domain is capital R. And if you look at step x values, always step x 0, step x 2, step x minus 2, step x 1. Range is always in integers, so range is set of integers and domain is capital R. Next, fractional part of x. If x is any real number, fractional part of x is denoted like this, and it is nothing but x minus step x. For example, what is fractional part of 2.6? Let us say this is nothing but 2.6 minus step of 2.6. What is step of 2.6? 2. Because it lies between 2 and 3 step. So 2.6 minus 2 is 0.6. Then what is fractional part of minus 3.8? As per definition, this is nothing but minus 3.8 minus step of minus 3.8. So this is minus 3.8. What is step of minus 3.8? Minus 4. So this is nothing but 4 minus 3.8, 0.2. And graph of fractional part will be looking like this. And domain. Fractional part is defined for all real values. And if you look at fractional part of x values, I got 0.6, 0.2. All fractions you will get, right? Which means it lies between 0 and 1, including 0, excluding 1. So range is 0, 1 with 0 closed and 1 open. So this is about fractional part of x, which is x minus step x. What is a 1-1 function? A function is said to be 1-1. A function f maps a to b is said to be 1-1 if different elements of set A have different images in set B. For example, image of A is x, image of B is z, image of C is y. Now see whether different elements of set A has different images in set B or not. Yes. So if different elements have different images, then the function is said to be 1-1 function or injective function. That can also be stated like this. If x1, x2 belongs to A, f of x1 means f of x1, f of x2 means images of those belongs to B. See, for elements of first set, images will be in second set. And if images are equal, then elements should also be equal. If x1 is not equal to x2, f of x1 not equal to f of x2. So if elements are different, A and B are different elements, their images should be different. That's what here x1 not equal to x2 means f of x1 should not be equal to f of x2. So the simplest way of remembering 1-1 function is if different elements have different images, then the function is said to be 1-1. That is the simplest way of remembering. Image of A is x, image of B is also x, image of C is y. This is not 1-1. Why? Because when we say that function is 1-1, when different elements have different images, here A and B are different elements having same image, and hence it is not 1-1. If a function is 1-1, any line drawn parallel to x-axis cuts the graph at only one point, at most one point. And any continuous function which is either increasing or decreasing is said to be 1-1. Any function which is either increasing or decreasing is said to be 1-1 function. This is another way of defining 1-1 graphically. Many one function. Just now I said any function which is not 1-1 is said to be many one. That is image of A, image of both are same. Here different elements are not having different images because A and B are having same image. It is said to be many one. Remember, any function which is not 1 1 is said to be any 1. Next, on to function. Any function f map said to be said to be onto if range and codomain are equal. We already know that range is subset of codomain, but if range and codomain are equal, then that function is said to be onto. For example, A is associated with Y, B is associated with X, C is associated with Z, D is also associated with Z. What is the definition of range? Set of all images. What are the images here? X is image of B, Y is image of A, Z is image of C. What is codomain? The complete entire second set B. Here range and codomain are equal. And then the function is said to be onto. Any function which is not onto is said to be into. If you look at this example, what is the range here? Set of all images, only X and Y, because Z is not image of A. What is codomain? X, Y, Z. Both are not equal, so it is not onto. Any function which is not onto is said to be an into function. Next, bijection. Any function which is both 1 1 as well as onto is said to be bijection. It should be 1 1 as well as onto, and hence it is said to be a bijection. Next, what is a composite function? Consider three sets. Let us say f is a function from A to B and g is a function from B to C. Then a function which maps from A to C is known as composite function denoted by G circle F. F is a function from A to B, G is a function from B to C. Then the function which is defined from A to C is known as a composite function denoted by G circle F. And G circle F of X is defined as G of F of X. G circle F of X is defined as G of F of X. This is what is meant by a composite function. Next, inverse of a function. For a function to have inverse, the first basic condition is it should be a bijection. If a function is not bijection, it doesn't have inverse. So remember, the basic condition for a function to have inverse is it should be bijection or 1 1 or 2. And inverse of a function is defined like this. If f maps A to B is 1 1 or 2, that is bijection, then there exists a unique function G maps B to A. This is f maps A to B. This is G maps B to A such that f of x is equal to y if and only if g of y is equal to x for all x belongs to A and y belongs to B. In that case, we say that Z is inverse of f and it is denoted with the G is equal to f inverse. If f is mapping from A to B, then f inverse maps from B to A. So this is about inverse of a function. Next, odd and even functions. Any function f of x is said to be odd if f of minus x is minus f of x. And it is said to be even if f of minus x is equal to f of x. So how to check whether the function is even or odd? Replace x with minus x first. If you get f of minus x as negative of f of x, then it is odd. If we get f of minus x as same as the given function f of x, it is said to be even. So this is about odd and even functions. So to know whether the function is odd or even, you need to find f of minus x. If it is minus f of x, odd function. If it is f of x, even function. It's periodic function. A function f of x is said to be periodic if f of x plus t is equal to f of x, where t is a positive real number. And the least value of t is said to be periodic. So, how to check whether function is periodic or not? Replace x with x plus t. What is t? A positive real number. If you get same function, if a same function is repeated, then it is known as periodic function. If t may have so many values. Out of those many values, the least value of e is said to be the period of the. Next, these are known as functional conditions. Functional conditions. If f of, first we'll look at the first one. If f of xy is equal to f of x plus f of y, then f of x is equal to k into log x. If f of xy is equal to f of x into f of y, then f of x is equal to x power n. If f of x plus y is equal to f of x into f of y, then f of x is equal to a power x. A power x. And if f of x plus y is equal to f of x plus f of y, then f of x is equal to k into x, where k is any constant. And we have one more. This is very important functional equation. If f of x plus f of 1 by x is equal to f of x into f of 1 by x, then f of x is 1 plus x power n if f of x is positive, and 1 minus x power n if f of x is less than n. This is also very important functional equation.